This week on Streaming Audio, we're talking about one of my favorite things to do with computers, where you just take an idea and you run with it. Pure creativity. Stuff where there's no stand-up, there's no backlog, there's no project manager, there's just one programmer saying, what can I build? How can I solve my pet problem? And what can I learn along the way? Well, today, Danica Fine is going to take us through one of her projects. She's been putting together hardware and software and sensors and wires and a couple of cloud services for a very interesting take on home automation. Before we dive into that, let me tell you that the Streaming Audio podcast is brought to you by Confluent Developer, which is our site that teaches you everything we know about Kafka, how to learn it, how to use it, how to grow with it. Check it out at developer.confluent.io. And while you're learning, you can easily get a Kafka instance running using Confluent Cloud. Sign up with the code podcast100 and we'll give you $100 of extra free credit to get you started. And with that, I'm your host, Chris Jenkins. This is Streaming Audio. Let's get into it. My guest today is Danica Fine, who is a developer advocate at Confluent. A fact I know well because she's on the same team as I am. She is a former Kafka developer and wrangler for Bloomberg. And you may have seen her as the face of a few release notes recently on the Confluent YouTube channel. Danica, thanks for joining us.
Yeah, thanks for having me. I'm really excited to be here again on Streaming Audio. So
Yes. As long as you say that the new host is better than the old host, or at least has better hair, then we can work with that.
No comment.
That's wise. That's wise.
Ask me afterwards, but yeah.
Okay, let's move swiftly on from that. So you and I share a hobby, which is learning things and researching things by mucking about with computers.
Mm-hmm.
Right?
Yeah, absolutely.
And you've come in to tell us about your latest research project.
It sounds really cool when you call it a research project. I like that. I'm gonna keep using that.
Okay.
But yeah, I think that I'm a pretty practical person, and when I learn new technologies, I really like to have a practical application of it. It really helps for me to understand what's going on. And so as my first project as a developer advocate, I thought that would be a good thing to do, right? For everybody else. I hope that everyone appreciates the practical nature of this. So yeah, I wanted to build out a Kafka pipeline, and I decided to make it a lot more tangible in my life and build out a hardware pet project as well. So now I have a lot of expensive hobbies, so it's great.
So tell us what it is. What did you actually settle on building?
Yeah, so I have a large number of houseplants. You see a couple in the background. There are many, many more elsewhere in the house, and it's kind of a hassle to take care of them. I love them, but every day I have to spend a lot of time checking to make sure if they need to be watered, if they need anything from me. They're very needy. So I built out a houseplant monitoring system to tell me when they need to be watered, so that I can get back those precious minutes of my day, right? So
and presumably never neglect them again.
Yeah, that's the hope. If everything works well, yes, they will not be neglected.
I'm getting the impression lack of neglect is a version 2 feature.
Yes, absolutely. That'll be in the release notes for version 2. Yeah, keep an eye out.
Well, let's start with version 1. How does this? Give me the overall architecture, and then we'll go through it. How do you do it?
Yeah. So, step 1, I got a Raspberry Pi, which are apparently in short supply right now. So I feel pretty lucky that I was able to get one. Yeah. And after a little bit of research, I found a couple of moisture sensors that I thought would work well for my at-home setup. I crimped a lot of wires, which no one really has to do. I mean, at this point, if you're a hobbyist, with hardware projects, you can get everything basically plug and play. I wanted to make it a little more difficult for myself and actually use, and just actually, wire everything up. So spent a lot of hours doing that. But yeah, once I actually got the physical system set up, so I have four sensors right now. I actually have a couple of them here.
Oh, yes.
They're
For the
really
people
cute.
watching at home,
Yeah.
Danica's holding them to the camera. For the people listening, it looks like a green rectangle with a black rectangle on the end.
Yeah, that's
And
a lot
moisture
of hardware projects. Yes. So this is like this is my first hardware project, and I just love how cheap and accessible everything was. Right. So like this was, I don't know, like $2 or something, and you really can't break it. I've tried. So we had a number of those, and they're all wired into the Raspberry Pi, and I wrote a couple quick Python scripts to intermittently pull moisture readings from these plants. And once it's in Kafka, from there it's pretty simple, right? And so the rest of the pipeline is transforming the data, and then I get a really convenient alert on my phone now when the plant needs to be watered. It's pretty cool. I think it's cool.
That is cool. Right, I'm going to make you take me through in gory detail because I want to know exactly how this works. So, I assume these moisture sensors are using the conductivity of soil. Is that where it starts? From how the wetter the soil, the more it conducts.
Yes, that's the general vibe there. There are a couple of different soil moisture sensors that you can get. These ones are actually a little hardier, right? They don't wear over time as much as other ones. So, so they're using they're capturing the moisture of the soil, and so I just basically have just a for loop checking that never-ending for loop every 2 seconds and pulling that information from all of the sensors. I also conveniently for free get some temperature readings as well. So
this is a thing. You often get these boards where they we have other sensors if you're interested for free because it's too expensive to do individual components, right?
Yeah. But the thing is, I don't actually, that's a nice to have reading. I am capturing it. But yeah, no, I've never really had a problem with my indoor plants getting too cold. So it's not very useful in this case, but maybe I'll find
You're out in California, right?
Yes.
Yeah, so I can see how the coldness wouldn't be, I assume, too bad a problem. Okay.
Not too much of an issue.
How does it work? Because I've only ever played with Arduino stuff. So I would be literally soldering one of those boards into pins on an Arduino. Is it the same in Raspberry Pi?
It doesn't need to be. So this is where it comes back to where I made it a little more difficult for myself and definitely didn't have to, especially for a first project. But yeah, so since I did opt for crimping all of those cables myself and setting up the connectors to plug into the sensor, in order to also connect all of the sensors and get them to use the same wires going into the Raspberry Pi, I had to connect into a breadboard. That did involve some soldering. So I am now adept at soldering. Well, I'm at least not the worst. I think so. So
is it a real hardware project if you don't burn yourself at least once with a soldering iron?
That is what I told myself. So I do feel fully initiated. In the future, I think I will choose maybe some easier things and not do it again like that. But yeah, so you don't need to do that. Like I said, a lot of these sensors that you can get are just plug and play. It's meant to be easy. It's meant to have like a very, very low barrier to entry. So it can be as easy as you want it to be, right? You don't have to get a soldering iron. You do not. I do not recommend that for people listening. Do not get one if you don't have to.
Especially for the people doing Raspberry Pi with their children. That's not a good time.
Yeah, it's not really. It's not that friendly. I remember when I was starting off soldering. Pretty much the same thing, right? When I was starting off, I live with a mechanical engineer, and I'm borrowing, the soldering iron from him, and he just walks in. He's like, don't lick your fingers when you're doing this, right? Because there's just lead. There's just lead in everything, apparently, still. And I'm like, I'm 3 hours into this. You're telling me this now? So not child safe.
I was once discussing one of these projects with a friend of mine, and he said, "What kind of extractor fan do you use when you're soldering?" I'm like, "What now?
Oh, was I
I'm not
supposed to get
supposed to
one?
breathe those fumes? They're so tasty."
Oops. Oh, you're not supposed to do that in a closed space? No.
Oh God, okay,
Ooh.
right.
Yeah. Good to know. Good to know.
So then Raspberry Pi, is it running Linux or is it running something simpler?
That is a great question. I set this up so long ago, and I pretty much just followed the setup instructions. Um,
Give me a Python
Offhand, I
prompt
do.
and leave me alone, right?
Yeah, honestly, like once I got it functioning, I stopped looking at the Raspberry Pi, like the actual operating system. Although before I had SSH set up, I did have to have it connected to a monitor, and that was pretty adorable because it's just really cute. And I'm like, no, I just want a command prompt. Just give me the bare minimum here. So it's so much easier to set everything up now with not having to plug the Raspberry Pi into anything and
Oh God, yeah.
and physically look at the UI. So
Right. So, okay, so you've got your Python script that's able to scan the external sensor running in a for loop.
mhm.
You get give me the data packet. Let's talk about how we make this into an event that we're going to ship off.
Yeah. And data modeling is extremely important. So it's a great thing to talk about. I think that it's very easy, when you build out toy projects or, things at home to just ignore the data model and, it get sloppy, cut corners, right? So I didn't want to do that. I spent a decent amount of time figuring out how I wanted this event to be modeled. So for the actual readings, so the temperature and moisture that we're capturing, that's happening in the same moment, right? Per plant. So I decided to put those into the same event, right? So per plant in an event, we have the plant ID, right? So I've given every plant an ID, like everyone, right? Everyone does that at home.
Yeah, absolutely.
Yeah. So I got our plant ID. We're obviously capturing some sort of timestamp, either just in the Kafka message itself. I also explicitly put that timestamp in there, just in case. We get
You
our
want the
moisture
difference between
reading.
internet time and plant time, just in case there's a discrepancy.
Exactly. Just in case that comes up later on.
Okay.
And then we also have our moisture value and our temperature value. The temperature, I think, is it's being captured in Celsius, and then the moisture value is a percentage of total possible moisture. It isn't like which is very bizarre to configure with the sensors. When you receive the sensor, they actually tell you when you start to set it up that you may have to configure this and figure out what the max and min value for your moisture sensor is, what makes sense for you. So I'm sitting there with a
Units of
glass of water,
wetness. Yep.
trying to figure out what's the max moisture of this sensor.
Yeah, surely a glass of water is 100, right?
You'd be surprised, but it really wasn't. I don't think it was. Yeah. Well, so it's a value from I don't know, 200 to 6,000 that the sensor just pulls out. And so basically if I treat, the 6,000 as being in a glass of water, I think it only got up to 5,700 or something. But then, I just translate that to a percentage. And so our every couple of seconds, we have our reading, which is our plant ID, our percentage moisture, and our temperature of the plant. So that's shipped off to Kafka. That is serialized as Avro, which
Nice.
I feel like the average person doesn't really want to think about serializing their data, but I feel confident that my data is robust and will not be changed later on in the pipeline. So there are benefits.
Yeah, I'm a fan of strong types. So
I've heard.
Try not to dwell too much on that topic this week. Is it hard to get the Python Kafka libraries running? Because I always feel something might be a bit hairy cross-platform.
Yes.
Because it runs
Yes
on the C
and
version, right?
and no. Yeah. So I ended up, I thought this was going to be a very, very straightforward thing. I mean, I guess in the end it kind of was, but I had to build it from source, libRD Kafka, in order to make everything work properly. Um, but doing that is not difficult. Building from source is pretty straightforward. Getting to the point where I realized I had to do that was a little complicated, right? It took me like an
Yeah.
hour or so, and I'm like, what is this error message? Because like everything starts running, and then there's like this one cryptic error message. So um, yeah. So if things aren't working, if someone's following along and wants to do this, and for some reason your Kafka isn't working on your Raspberry Pi, in a very specific use case, just try building from source. I think it'll work. I think it'll be fine.
If all else
Pretty good
fails.
solution. Yeah.
Okay, so then you're off to the races. The data is heading across the wire to the cloud.
It is in motion at that point. Yeah, it's crazy.
In motion, as we like to say around here.
Yeah. So we have our event, right? But that event isn't super useful without some additional information, some metadata, for lack of a better word. So I also, I'm only monitoring like 4 plants. Sometimes I switch them out, so I have like 6 or 8 plants that I actually keep track of with this system. So I had to write some metadata on those plants, right? So I have my plant ID in my reading. Plant ID. So I had to tie that plant ID to an actual plant so that when I'm looking at an alert, I actually know what's going on, right? So I also wrote a simple script to leveraging an Avro schema, write some of that plant metadata into Kafka as well. And that contained, a lot of what I think is useful data. So we've got the plant, per the plant ID, we have the given name of the plant, because all of my plants have names. Yes.
They have names and give me an example of one of your plants' names.
So this is Olaf, and I have a plant on my desk. So here's a plant. But so Olaf is his given name, but then there's the scientific name. He's a type of Dracaena. There is a common name for that plant that might be useful. That's a dragon plant for some reason.
Dragon plant.
Doesn't really look very menacing, but okay. So those are the fun things that I've got in there. And then also the useful metadata, which is, okay, for that plant, what is the lowest bound of moisture that this plant is comfortable with?
Right, yeah.
Right?
Which varies by species, right?
Yeah. So, I mean, I think generally it's very similar for most plants, but some plants have a lower tolerance or a higher tolerance, depending on how you look at it. So, like that plant, for example, I don't even remember the last time I watered that plant, because they'll just keep living. It's totally fine. So that one may have like a 10 or 15%, moisture boundary, right? Lower bound. I also, just in case, have like the upper bound in there. I've definitely oversaturated this plant. Let it dry out. Yep. And then I also have the similar data point for the temperature, right? So house plants should not get below, a certain threshold. My house will never get that cold, hopefully, unless there's a second ice age in the next year or so. But
it's almost believable,
yeah.
But
actually,
if that happens, the wetness of your plants will be the least of your worries, right?
That is true. Yeah. That is true. Also, pleasant, like kind of reassuring a little bit. That's fine. So I have my readings going to Kafka. I've written my metadata into Kafka, and now I can actually start playing around with the data, which was the fun part, I think. The really fun part.
Tell me the fun part. What do you do with all that raw data? How do you munge it up? Yeah,
so I set up a Kafka cluster in Confluent Cloud, which was actually, you mentioned earlier, my past experiences with Kafka. I was a software engineer building out Kafka applications, and it's different when you're at a company and you have Kafka, provided to you and whatever. Doing it on your own is like a little more intimidating, right? And I think that having Confluent Cloud available to me was made it just that much easier. It was so cool to just be like, okay, here's my cluster. Okay, just start writing. It took like 3 minutes, right?
Yeah.
It was pretty cool, pretty easy to get that up and running. So yeah, I have all of my data in my Confluent Cloud cluster, and I ended up using ksqlDB to transform the data. So at this stage, I didn't even have to write any additional code, which was pretty cool. It's pretty nice to just transform the data with a couple lines of SQL. So
what sort of transformations are you doing?
yeah, first I'm just registering that data in the ksqlDB application, and then so the readings data I treat as a stream. It's an unbounded stream of events, hopefully, unless someone unplugs the Raspberry Pi. And the houseplant metadata is a table. Every so often, I might like play around with the lower bounds of the houseplant, so I just write a new entry to that table, if you will.
Yeah.
And so I've got my stream and my table, and so in order to make sense of the readings, I need to enrich it with the houseplant metadata, right?
Yeah.
So there's an enrichment stage, or like just a basic join, if you will.
Yeah.
And then from there is where it gets interesting. How do I actually alert on this data? How do I make a decision based on this data? Obviously, what I want to be doing is saying, oh, when a reading comes in, and once I've enriched it, I need to check if that moisture reading is lower than the lower bound for that plant, right? Because then I need to water it. But we're taking readings every couple seconds. So if I just alert on that every couple seconds, my phone's going to explode when the plant needs to be
that
watered.
urgent, right?
Yeah, it's not. So I was like, what would be a reasonable amount of time to be alerted? Probably twice a day or like every 12 hours. If I forgot to listen to the first text, I should probably, water the plant on the second one. So I aggregated the data, right, based on those outlier readings. If the moisture is lower than that threshold, I aggregate that per 12 hours. So,
okay,
and that's
so
also
you're doing session windowing.
I am doing windowing. It's just a non-overlapping window of 12 hours. Again, so simple to do. And SQL, oh my goodness, it's like, it blows my mind. So prior to this, I've really dealt a lot with Kafka streaming applications. So going from that to, we're just going to write 5 lines and it's done, right? Like to window in SQL, like so much easier. So I window over 12 hours, and then I need to decide like, okay, well, what is the number of low readings that I would have to get in that 12-hour period to warrant an alert? Because sometimes, these sensors, it's a $2 sensor, right? Sometimes it might give a faulty reading. It just might. Yeah. So I want to make sure it's absolutely certain that it's a low reading before I send it down the pipeline, right? So chose like an arbitrary number, like we should get 1 hour worth of low readings in a 12-hour period to warrant an alert later.
Right.
So yeah, which is also, pretty easy. I just say, okay, when we get to that many readings, send it off. Yeah, it's crazy. It's so crazy how easy this was. I loved it.
I sort of wish we could hold up the SQL query for the folks at home, but that's not going to work for the podcast. So,
if I just hold up a blank piece of paper, can we just? You think they can edit on there, like post-production?
I think the YouTube people will be fine, but this really not going to work for the for the listeners. So we'll link to the show note to the repo in the show notes. But
okay, yeah, definitely.
Okay, so you've got this query that is denoising and aggregating, so it doesn't send out too often.
Yes.
And while we're talking about things we like about KSQL that aren't writing Java streams, I'm going to throw in my favorite, which is it's just deployed. Your stream processing app is just, I typed in 3 lines and now it's deployed, which is great. So But how? Okay, so take me into consumer land. How does this event get out to your pocket?
Yeah, yeah. So, also, this is pretty cool. So, I got the idea from our other esteemed colleague, Robin.
Hmm.
He had written a some use case where he leveraged a Telegram bot. So everyone has Telegram on their phone, that messaging app,
Yep.
and they make it really easy for you to set up your own bot. If you just wanted to play
Do
like
they?
to fake AI, you can write whatever you want. It's pretty cool. So it takes a couple minutes to set up a Telegram bot, and once you start interacting with that bot, you get a chat ID,
Hmm.
and then they have an API that you can just reference that ID and send messages to yourself from that bot. So naturally, I had to create a plant alerting bot that will yell at me when I need to water my plants. So I set up that bot, and using the API, the endpoints that they provided, along with that chat ID, I could then use the HTTP sync connector and
Oh,
write that data out from Kafka to my
I've
phone.
assumed you're running your own consumer somewhere,
No, this
but
is even
this
easier.
is just a regular old connector.
Yeah, it's great.
Oh,
And
cool.
to make it even better, like it's fully managed as well. So through this whole process, like outside of the Raspberry Pi thing, I never had to leave the Confluent console. Like it was just all
Okay, that's quite cool.
just set it up there. Yeah, pretty
And
easy
it's
for a
not a
home
dedicated
project.
Telegram bot, it's just the HTTP one. Sorry, it's not a dedicated Telegram connector.
Yeah, it's just the HTTP sync connector.
That's
That's
pretty
it.
cool.
It's awesome. Yeah.
Okay.
So I was like, able to just point to that endpoint, and then also in the configuration point to that topic that I was aggregating that data in,
Mm.
and extract just the message that I wanted to send out. Um, it's so simple. I keep saying that. I keep saying that, but it's like I'm just baffled that for this first hardware project and pipeline that I wanted to build that was useful in my house, in my life, something I wanted. It's
Yeah.
crazy that it was like this easy to set up. I built something that I actually needed in my life in not that much time,
From
right?
scratch.
Yeah, it's so cool.
Yeah.
It's like, looking back to my other experiences with software, it's like, it's one thing to be like, oh, you like to tell people, I built this thing, I built this application or whatever. But unfortunately, if it's not like a front end component, like it's not something tangible you can't properly brag about it, you know? But now if people come over, I'm like, yeah, I built that thing. It's over there and, it monitors my plants. Look, I got a text. It's like, it's pretty cool. It's got a wow factor, I guess.
Yeah. Little blinking lights by the shrubbery.
Yeah, that is. I got to get more blinking lights. I was thinking of like wiring some extra ones in there, like as a
Nice.
second, so I don't even have to look at my phone. Like, what if there was just a light that or like a sad face on the plant? Like, I gave
Yeah.
each of them a monitor.
Yeah, I think that would be,
Just-
you should have each plant as a consumer of its
yeah.
feeds. And it can be like really sad if it's thirsty and a little bit sad if one of its friends are thirsty.
Yes, it's like real life Tamagotchi. It's going to be great.
Yeah.
I guess real life Tamagotchi would just be having a pet. Um, but I've got plants are a little cleaner, so
Definitely, definitely. They're the low maintenance children.
yeah.
So is that something you're actually planning to do? This enhancement. Where next for the project?
Yeah, so that was something, that I feel like I joked about from the beginning, but I think it would be pretty cool to kind of like complete that pipeline and have like another set of consumers pushing back to the Raspberry Pi. Um, that's something I would want to do. I would also like to make it easier to write metadata to Kafka. So I was thinking of like building out the Telegram bot to also accept like input to register a new plant. Um,
Oh, cool.
and then, of course, I feel like every one of these projects, you got to build like some sort of visualizations. I would love to see a chart, maybe add some, machine learning in there to anticipate when,
Yeah.
beforehand, like when I need to water the plant, based on historical trends, right?
Yeah.
How much do I neglect my plant, So yeah, there's a couple of extra directions that I want to take this in. So we'll see. We'll see.
Cool. That'd be groovy. Do you know what it makes me want to do? This is revealing my own extracurricular activities, but you can get sensors that will like sense O2 levels, right?
Mm-hmm.
So
Yeah.
can I connect one of your system to an open bottle of wine and it will tell me when it's breathed enough to drink?
Oh, that's good. I did
Yeah.
have some things in mind for, another, I call these practical pipelines, but I don't know if a pipeline based on, an application based on wine would really be that practical, but that's good. There's a subset of people out there that would care, right?
Yeah. Actually, there's probably a
So,
really, really rich subset of people that would care a lot, right? That's how the
yeah,
wine market works.
new startup idea, throw in some Bitcoin and you're ready. This is going to be great.
Great. So if people want to follow in your footsteps, where do they get started?
Yeah, so I'm actually I'm in the process of drafting a blog post to outline everything, because I think that this was, as I've said a couple times, it's too easy not to do it. It's like it's a really fun thing. You gain practical skills. I have all these ideas in my house for like weird, hardware things that I want to do now. I'm like, oh, there's a sensor for that. I can do it.
Cool.
It's pretty cool. So yeah, so there's an associated blog post outlining pretty much everything that you need to do, as well as pointing to a repo with code snippets that might be relevant. So yeah, I want everyone to know that they too can be a hardware hobbyist.
Oh, cool. Yeah. Well, if you're tempted to follow along with that, I'm sure by the time this podcast goes up, your blog post should be up too. So we'll link to that in the show notes as
Yes,
well.
absolutely.
Danica, you make me want to go and break out some Arduinos and do some damage.
You should. Why not?
I really should. Well, thank you very much for joining us.
Yeah, thank you for having me. It's been fun.
We'll catch you next time.
All right, bye.
Our very own Danica Fine there, doing a far better job caring for her houseplants than I've ever managed with mine. As I said, if you want to get more details or you want to see the code for that project, then check out the show notes. We'll put the links in there. We'll also put our contact details in the show notes. So if you've got a question or a comment, or you'd like to be a future guest on Streaming Audio, just drop us a line. Or you could leave us a comment or a thumbs up or a review on whichever app is currently streaming audio into your life right now. Before we go, let me remind you that if you ever want to learn how to hack together your own event system, then you should take a look at developer.confluent.io, which is our site that should have all the guidance you need. You'll also find a few courses on there that are taught by Danica herself, so you can learn from someone who has both the knowledge and the battle scars to prove it. If you need a Kafka instance to run your own project, then head over to confluent.cloud and sign up with the code podcast100, and that'll get you $100 of extra free credit to run your project with. And with that, it remains for me to thank Danica Fine for joining us, and you for listening. I've been your host, Chris Jenkins, and I'll catch you next time.